All right, so another request for 8.3. Let's take a look. So, again, we have a function with no inputs. So k0.1, k0.2 is a multiple of k0.1. That's good. Activation energy in calories per mole. Actually, I think it's kilocalories per mole. Okay, so to get it in joules, also need to multiply by 1,000. Okay. Then there's R, right? Just to make sure I'm not mistaken. Yeah, it's kcals. Okay. Oh, but then again, you had scientific notation there. You had e to the 3. Okay, so that's good. So activation energy in calories per mole, convert to joules. There's R and T. Initial concentration of A, B, and C. That's good. Stoichiometric coefficients. So here we have A goes to B in reaction 1. B goes to C in reaction 2. So this is my series case, which would be good to note and say the documentation up top. You go ahead and you calculate your rate expressions. That's good. Create a vector of tau values. So you're saying tau in minutes. Okay, if tau is in minutes, your pre-exponential terms in seconds inverse. So the units of time just need to be consistent. So take a look at that. And you create a vector of, what do we have here? CTC, so you're going to have a concentration matrix, it looks like. That'll have 4 rows. And then the number of columns. So basically you're creating a matrix of all zeros. So you could have also accomplished this as CT is 4 comma length tau or 0. So another way that should work for this is so basically you're going to end up with a matrix that has 4 rows, and then in terms of columns, you're creating a bunch of columns of zeros, right? You're doing this 4 times, and the number of rows you have is going to be as many is the same as the number of elements you have in that tau vector. Okay, but you can also do CT is equal to zeros 4 comma length tau, right? If you wanted to accomplish that in one command, okay, but that's not necessary. Okay, this is underlined, suggesting it's not used, but we only have A, B, and C, so we'll see what that 4th row, which you're using it as. All right, so then you create an error function where the only unknown is going to be CT. And you pass your initial concentration, stoichiometric coefficients, K1, K2, and then that's your vector tau. Okay, tau is a vector. And then you're attempting to solve, it would seem to me that you're trying to vectorize fsolve, and that's not quite right. And not only that, you have 4 unknowns you're trying to solve for. You're trying to solve for CA, CB, CC, and FA, right? FA is really not an unknown. It's really not, because it's just your initial concentration of A minus your final divided by your initial concentration of A. And so it's not really an unknown you'd put in there. It's something you're solving for. So those rates are set up fine. Your mole balance design equations are set up fine. Okay, fractional conversion, sure, let's see if it works included in there, and you pack it up. Okay, this looks like something you tried to use before and it's not working. Okay, but I think the biggest issue here is, let's see, so CT, CA is CT, so CA would be row 1, all columns. Yeah, so you're trying to vectorize fsolve, right? There's no vectorizing fsolve in F0. Well, Oh yeah, think about this. So basically, you have a massive number of unknowns, right? So in terms of unknowns, um, you're saying you have a vector of, it's the matrix is going to be a 4 by 100. Okay, so 4 by 100, you have 400 unknowns that you're trying to have f solve solve for. Okay, so in your error function then here, okay, that's fine, but I don't think you could, even if we were to try, if you want to try and solve for 400 unknowns, we could do that. But this, is that going to work? Yeah, I suppose so. Okay. All right. Now, those would be row vectors. And so then you're packing the row vectors on top of each other. Okay, so that order works. So then, if this did, by some miracle, work, okay, where you would get an error message is I need to give initial values or initial guesses of 400 unknowns. So what I could try and do is, if you want to do initial guess of all ones or something like that, let's do this. Hold on. Sorry, I should make this bigger. So what I'm trying to look at is your fsolve call. Right now you just have initial guesses for 4 quantities. You would need 400. Okay, so let me create like an initial guess matrix. Okay, and maybe my initial guess matrix is CT naught, and let me just do ones. I'm gonna do ones, 4 comma length tau. Okay, so we can have an initial guess of everything is 1. If you want to change it, we can. And so then here, I'll do CT naught. Okay, now in theory, I suppose you could do this, but I'm having a hard time picturing getting this to work. It says it solved. And then it says you have an issue with figure. I must say, if this actually works, I would be incredibly impressed. Okay, now one issue here though is res is just CT, right? So can't you just do CT as res? But let's come back to that. Oh, so figure 1. My God, it actually works. Okay, so what this is telling me is let's make this bigger. Yeah, holy cow, that actually works. This is quite the impressive solution. Okay, this is quite the impressive solution. So then what I would do is, instead of res, there's really no use for CT up here. Okay, there's no use for it because CT, right, is my input to my function here. And so what I really want then is just CT is my solution. Right, if you want to use the CT matrix. And I have to say, this This is very impressive. Now, so it's very impressive, but then it also begs the question of fsolve, right? So if I were to set up a for loop, as I would do, and I loop over, say, a vector of tau values, and for each tau, I solve my system of 3 equations for 3 unknowns. Okay. Is it better to numerically solve that, or what you've created is you created a system of 400 equations with 400 unknowns? Okay, so computationally, what's better would be a matter of debate. But you have fractional conversion, you have selectivity. Yeah, it works. So you've created a system of 400 equations with 400 unknowns that you're solving. Now, one thing I would probably do is I wouldn't solve for fractional conversion like that. All right, so we can make it a system of 300 equations with 300 unknowns. All right, and how I would do that is, okay, let's just copy this expression you have here. Okay. So it worked the way you had it, but there's you don't necessarily need to. Why is this CT? Well, we'll come back to that in a second. So what I could do is I could do. How would I do this now if I wanted to make this? So this was your 4th element. So we could do CT row 4 all columns just like you had is equal to, now A is CT is my first. Oh yes, CA, that's good. So I could just go ahead and compute that. Why you're dividing the fractional conversion by that, I don't know. So what I think we have going on here is this is actually time in seconds. Okay, so if you want to convert your time, converting the space-time to minutes, that's actually tau. It's actually tau. Yeah, I call it tau. And now, that's not CT, that's tau. Okay, so let's try this again. Okay, so I had some green up here, so or orange. Let me see what that orange is. Okay, so still working just the same. Okay, so now when I have this non-square issue, that means I have more unknowns than equations and more equations than unknowns. Oh, and it's going to be because I didn't update my initial guess. All right, now I just need a 3 by 100 matrix. Okay, because now I'm just solving for concentrations, not fractional conversion. All right, so now it's square, so now it works. All right. I mean, I gotta say, this is quite the impressive solution. All right, nothing's being returned as res. So if you wanted to, you could, return, say tau and CT, your matrix of concentrations, if you wanted to. And if you wanted to generalize this, let me make an input of multiple, and then let's just take that multiple that you're looking at and multiply it by k0.1 to get k0.2. Okay. But yeah, it works. It's good. You didn't need to pre-size CT. Instead you could just store your results as CT, and then it gets its size there. Yeah, it looks like you had an extra error function here, so this isn't necessary, so just go ahead and delete it. And yeah, so it works. Again, my only comment would be, in terms of efficiency, what's more efficient? I don't know. So in my version of the code, I'd create a vector of, say, 100 tau values, and I would set up a for loop where each loop iteration I just solve for that specific value of tau. All right, and so I would 100 times solve a system of 3 equations with 3 unknowns. What you've done is you've instead created a system of 300 equations with 300 unknowns. So you're asking fsolve to solve a system of 300 equations with 300 unknowns. Okay, which one is numerically best or more efficient? That isn't clear to me, right? Because it's not quite exactly the same thing as vectorizing your code, but it simply does make your code look nice and compact. Okay, so yeah, I don't know what the answer is in terms of most efficient, but I never even would have thought of solving it this way, and you just showed me you could. So thank you for that.